Hi, in this video, we're going to solve a problem which appeared in JEE Main 2019. In this particular problem, it says that we have a quadratic equation x square minus mx plus 4 equal to 0 have real and distinct root, but they must lie inside the interval 1 to 5. So what will be the values of m, or like means what will be the value of m possibly in which interval it will lie? That should find out in this particular problem. Let's go ahead and solve. So first we consider the equation, right? X square minus mx plus 4. Now here we consider the equation as fx equal to 0 and fx is x square minus mx plus 4. Okay, that's it. Now here, right, it's given that alpha and beta are the two real roots of this given equation. Now, as alpha plus beta are the two roots, so therefore, if we plot it, the graph of fx must cross the x-axis at these 2 points. Okay, that's the first information. And also here notice that coefficient of x squared is 1, that is greater than equal to 0. So therefore, it is represents a parabola open upwards. The roots lies inside 1 and 5. So that's the second information. And as alpha beta is the root, so therefore it cross the x-axis at x equal to alpha and x equal to beta, and then these two alpha beta must lie inside the interval 1 to 5. So let's try to sketch the graph. So first we consider the x-axis and y-axis, marks the point 1 and 5, and then we draw a parabola which is vertically upwards. And wherever it crosses the x-axis, that will be the roots alpha and beta. That's it. Let's go ahead. So first, we can consider the condition 1, right? So that alpha beta lies inside the interval alpha 1 and 5. So the first is that is given alpha beta are the real roots and they are distinct. Now, whenever if equation have a distinct real roots, the discriminant must be greater than 0. What will be the discriminant in this equation? B square minus 4ca. Here B is minus a and c is 4, a is 1. So therefore, b square minus 4ca gives m square minus 16, and that's greater than 0. If we factorize, it will be m plus 4, m minus 4, it will be greater than 0. And this equation will be satisfied if m is less than minus 4 and m is greater than 4. So therefore, we can say that the equation of the condition will be satisfied if m belongs to the interval minus infinity to 4 and 4 to infinity. So let's go ahead and mark this region as A, right? So therefore, we consider a number line marks the point as minus 4 and plus 4 and the region. So it's less than minus 4 and greater than 4, right? And that's it. So now our M should lie in this shaded region. Let's go ahead. Now in condition 2, we consider that the roots are lies between 1 and 5. So therefore, right, we can say that alpha and beta, right, are the roots of the given equation x square minus mx plus 4. So therefore, alpha plus beta is equal to m, sum of the roots. And here alpha and beta belongs to 1 to 5. That means alpha and beta lies inside the interval. So 1 less than alpha less than 5, beta 1 less than beta less than 5. If we add them together, right, we can get it as 2 less than alpha plus beta less than 10. So therefore, m lies between 2 to 10. So therefore, m belongs to 2 to 10. So the second condition will be satisfied if m lies between 2 to 10. So let's mark the point 2 and 10. Okay, let's mark the point 2 and 10. So m belongs to in this interval. So this condition need to be satisfied as well. Let's go ahead. Let's go ahead and take the condition 3. Now, let's observe the graph. You notice that f of alpha, f of 1 is greater than 0, right? So therefore, we just substitute that x equal to 1 in the expression of fx, right? So if we substitute f1, right, it gives me that 5 minus m. Now, this value should be greater than 0. So therefore, 5 minus m is greater than 0, m is less than 5, and that's the third region, right? So third region is minus infinity to 5. So let's mark the point 5, and every region, right, from less than 5 will be our desired region, right? That's it. Let's go ahead. Let's go ahead and go for the condition 4. The fourth condition will be a5 is also right greater than 0. So let's calculate a5, which gives me that right 29 minus 5n, right? So this is the value. So here also 29 minus 5n is greater than 0. So therefore we can say that n must be less than 29 by 5, which is equal to 5.8 approximately. So therefore m belongs to minus infinity to 5.8. Now let's mark the point 5.8 and any values less than that, which is shaded in a reddish one, right? That gives me the requirement, right? That's it. So here we find out the possible all the conditions so that all the alpha beta will be a root. They are distinct, lies in 1 to 5, f1 greater than 0, f5 greater than 0. So we need to, if all the condition is satisfied, then only, right, the roots will lies in that interval. Therefore, M should belongs to the intersection of all those interval A to D, A intersection B intersection C intersection D. Okay, that's it. So first, let's go ahead and mark this region A, now B, now C, and D. Now let's observe that, right? There's all the condition will be satisfied, then the intersection will be that shaded region, right? That is the problem, right? So now, if that shaded region we perform, right, we can say that this is the shaded region. So therefore, it lies between 4 to 5. So in that 4 to 5, all the four conditions, whatever we mentioned, is satisfied by this, right? So therefore, we conclude that, right, A mass belongs to 4 and 5 so that all the condition is satisfied. So therefore, for this particular problem, we can say option A is the correct answer. And that's it. Hope you understood the problem. Thank you.